not seen practically any IC. So that's why it is very hard to believe for you also. If at all, I will go to your analog electronics and relate it. You know the op-amp, right? You think like this? Yes or not? You have the op-amp or not? Yes.
Yes,
okay.
ma'am.
Now, why I am relating this one means your op-amp is an IC, right? It is a 8-pin IC. Okay, and if you remember, these are, and I don't know how many of you have remembered the pin diagram. This 2 and 3. This is pin number 2 and 3, which is fixed. And similarly, VCC and minus VCC. This is also fixed. The pin numbers are fixed. Okay, where the output should be, I think 3 is the output, I guess. Yeah, 3 is the output. Okay, I think here 1 and 2. Okay, so these pin numbers, in fact, the IC will be like this. This is your IC, and every pin is having a dedicated work. Okay, so now in this particular one is very important. This is, apart from these two, there is another power supply. Plus, okay, now what if 4? This is out of the box. What if 4 is not given any 5-volt supply? This and this are having 15-volt supply. That is secondary. This one is given 5 volts. Now, what if 5 volts are not provided to that? Yes, I'm asking your views.
Ma'am, what is this chapter means?
What is this chapter? I'm not talking about chapter. Abhishek or Abhijit has asked me the importance of a clear pin. So I have started another chapter. Oh, it's nice. I will start analog also for you. No, I am talking about the importance of pins, pin diagram. You have any idea about this pin diagram? What do you mean by pin diagram? You have come across any time this one?
No.
No, na? Is it yes or no?
We have pin
is
diagram.
Is
And
Abhijit
we
there?
have
Abhijit ready. Abhishek ready. I don't know. Is he there in the class? He was asking me regarding the idea of what is clear pin. What do you mean by clear pin or clear control? See, yesterday I told the word preset and clear. How many of you have really followed what exactly is a preset and what is clear? Clear means what? What are you clearing? Now, if at all you take, this is a flip-flop box, and I am telling I have a pin which is called clear, and if I ground it or if I change its state, the contents will be getting emptied. This is what I am telling. So how many of you can really follow that clear word? See, be frank, because if you don't understand, there is no point of working out on this, because from now onwards you will be getting this type of terms. Because we are moving slowly into the embedded systems. Digital is almost over. We are going into systems. When system is coming into picture, we require this type of control pins. So, did you understand the meaning of a clear? Everyone, anybody who understood, like you can openly talk, right? So, should I point out the Shruti Kumari?
Ma'am,
Yes. What did you understand by clear?
ma'am, if we apply clear, then whatever will be inside that is presetted, it will be removed.
It will be removed. So it is okay to believe or something fishy in that?
No,
Means it is okay to believe. Okay, very good, very good. Samir?
Yes, ma'am.
Okay. So what happened about here?
Ma'am, it will clear the output of the flip-flop, I guess.
Okay. So it will clear the content. We can say content. Okay. So here you have used the word output. output, no? So that time output has come after giving the input only. So it is reacting for the flip-flop. So basically what you told is technically correct. Output is removed. For that particular input, some output is generated and we are clearing it. Correct. So now if I use the word preset, what did you understand by that? Preset. Preset, preloaded, loaded, all these are technical terms for the same thing. What is that? It is like a predefined thing we are already keeping into that. We are making it enter into that. Is it possible to keep like that? It's like a wallet and we are keeping some money in that. Like that it is. Preset. Did you remember that? Please, preset. Yesterday I was telling that word. Yes, Samir. Preset. Yes or not, Samir? And who else is there?
Yes, ma'am.
Swaroop. Yeah, Swaroop always interacts. Dinesh.
Yes, ma'am.
Yes, Dinesh. What happened?
Ma'am, nothing. Ma'am, I just joined now.
You have just joined now, so I just wanted to ask, what did you understand by preset? Nothing?
Hello.
Yeah, I can listen, Dinesh.
Ma'am, I didn't get you, means I didn't hear.
What do you
what you
understand
said.
by the word preset?
Reset.
Not reset, pre, P-R-E, pre.
Reset. Ma'am, I can't explain it. Means in.
But yesterday you could understand something. Yesterday did you understand? Because I was using the word preset yesterday. No. Yesterday you have not come. Okay, fine. No issues. Okay, I use the word load also. I use the word preset also. Doesn't matter. Okay. So now, why I have drawn this one, this circuit, just to make you understand, since you have already studied this op-amp and where a pin diagram is already established for you, that means every pin has a purpose. Right? It has to obey that rule. Like for example, you can mute now. So this particular issue of giving VCC, that means this pin 4 has to be provided some 5 volts. If not, the system won't work. This is a system for us. One IC means a small system for us. It has to be enriched with all these extra effects. Like ground has to be provided, VCC has to be supplied, input has to be given. Then only we can get output. Otherwise, how we will do? So similarly, in the yesterday's class, I was trying to tell you there are some control pins which are dedicated. Though we have studied the flip-flops like in a different manner. Like I introduced the flip-flops through gates. Right. It is not the end of the flip. You have apart from that muted. You have apart from that so many other control pins. Okay. So many other control pins do exist. Right. So now, yesterday, where did we stop? We stopped regarding, I don't know, Abhijit has came and told, and then afterwards. Anyway, so we are with mod 4 counter. Okay, this is just an example and a modulo we will tell 4 counter. Right. So I wanted to have 4 states. Clearly understand. 4 states or 4 sequence state. Somebody's mic is on, I guess. Yeah. Right. So we want 4 states to be indicated or to be given as an output. Now, what do you mean by state? State is nothing but a level, a maintenance of the level. What we say is, okay. So 4 sequence are 4 different. That is what we have to understand. Here, modulo counter doesn't mean always it should be in a sequence. The digits should not be 0, 1, 2, 3. This is not only 4. I can say 7, 9, 10, 15. This is also 4 states. 4 different states. And this is 4 sequence states. This is what the difference. 4 different states. It has to show 4. Now if you see here, what should be 7 means digitally? It is taken as this. This one, it is given like this. This one, it is given like this. This one, it should be like this. All are different, right? Now, question comes, if at all I start with 7, I should end with 50. Okay, but this counter has to not to be moved in a sequence. It is not even in a normal way. Okay, hold on. There is a glitch here. This particular one is not in a sequence, but still we have to give the output. How we can generate, by the way? Okay, take this as a synchronous counter. Take this one as a synchronous counter. Right? This is a synchronous counter. Please, can you design this for me? 7, 9, 10 and 50. This is present state. The next state. Yes, quick. You can use the P flip-flop if you want. The next state is okay. This is my state table. Is that correct? Yes or no?
Yes, ma'am.
Yes.
Okay. Now,
Yes.
yes. Now I want TA, TB, TC, TD. That's synchronous. I want synchronous.
Yes, ma'am. 1110.
Quickly. I was telling that there is a problem here. Am I audible?
Yes, ma'am, you are audible now.
Yeah, but video is not there na, because bad quality network it is showing here. For me.
Ma'am, that 1110 is in the horizontal form.
One. Okay, fine.
Zero zero 11.
0,
0101 1000.
Okay. So now I will get immediately TA, TB and TC. Sorry, TC, TB. Then I will get the current. Right. I am talking about synchronous, not asynchronous. We will go to the asynchronous immediately. So what is TA, TB, TC? Are you planning to take the rest of the things as gifts? Because they never show up in this sequence. Is that correct?
Yes, ma'am. Can we take?
Yeah, you take. They never show up in the sequence. The already predetermined sequence is given for you. Predetermined states are provided to you. So you can take. It can further reduce us. Yeah, it's interesting. Now we can go. Are you guys there or not?
Yes, ma'am.
Yes,
There.
ma'am.
Okay. What happened to TADB? No.
Ma'am, TA will be BCD.
TA will be BCD. Okay. You have taken
I'm using
the.
document CD.
TA will be B.
Ma'am, it will be CD.
Oh God.
Only B.
I'm only B.
B is very small, so I will take that one. You have taken don't guess?
Yes, ma'am.
Yes,
Yeah,
ma'am.
good, good, good. Take don't guess.
Yes, ma'am. B.
Ma'am, DB is A prime plus D prime.
B.
A prime plus C prime.
C. B.
B prime.
Okay. Now, so designing a synchronous counter for these many states. This is 7 state, then 9 state, this is 10, this is 50. So not at all in a sequence. They are just like that 4 different states. And you got your inputs, right? Synchronous one, because we have a procedure, we could do that, and I can tell that this is a modulo 4 counter. Modulo 4, not sequence counter. Modulo 4 counter, which gives 4 different states. Okay. Now, if the same, and I can complete the combination because I have already have the inputs what to be given. Okay, right. Now, if the same thing I have to design by in a asynchronous mode, please try to understand. If the same situation I have to take it in a asynchronous mode, do we have a way? Point number 1. Please now be free to discuss on this because asynchronous doesn't have any rules. And moreover, asynchronous is like clocks are interconnected. One output is acting as a clock to the other one. So in that scenario, can I have a synchronous design for the same states? Because synchronous is very easy. We have a particular procedure and in fact it's very good and you have completed. So if at all I show it's in a complete block, it works. All the states will come for every clock pulse. Timing diagram also is easy. That. But if at all I want an asynchronous, can I get? That is question number 1. Can we have this mystery solved for asynchronous? Yes. If at all you have understood, you can.
Ma'am.
Yes.
Ma'am, maybe we can use normal 1 to 0, 1, 2, 3 state and then use an encoder to convert them to 7, 9, 10, 15.
Now you see, now the question comes, if at all they are not in a sequence and they are completely different states. Asynchronous counter, I'm talking about how difficult in order to analyze the asynchronous. Why? Because 4 different states are there and we cannot do the connections also. action instance, what goes what. Is that correct? Afterwards, how I should give. Most important, what should be the inputs? Just like you have designed TA, TB, TC, TD. What should be the input? If at all I go for the asynchronous mode. Can I have a way out to get this one in asynchronous? No. What did somebody told? Maybe we can use an encoder. Is that correct?
Yes, ma'am.
Encoder where?
Ma'am, add the outputs. We can take the output from the counter and then encode it to get the desired state.
But the counter should be asynchronous, no?
Yes, ma'am.
Asynchronous has a rule. Will it follow that asynchronous rule? I don't think so. Correct? Yes, why? Nobody is giving a response.
Ma'am,
So,
I think,
ma'am,
One at a time.
ma'am, the numbers that are there 7, 9, 10, 15, they do not following any order or sequence. So designing them.
Okay, hold on. So that means you are going to give a statement. The sequence order can be designed in asynchronous. Correct?
Yes, ma'am.
If like this type is there, it cannot be designed in asynchronous. Can I make it as a statement? Because this, what is the difficult? By the way, again, can you repeat whoever is telling? What is the difficult? Because the analyzation of what input should be provided initially, so that the sequence continues. This particular sequence continues is the result to be followed. Correct?
Yes, ma'am.
That is what is a big headache. We cannot estimate or we cannot predict what goes next. Okay, that is one. Another one, somebody else is telling?
ma'am, same thing.
Same thing. Okay, right. So now, if at all I will say, use it a modulo counter. Clearly understand. Now I am using a new counter called modulo counter and we don't know anything about it. What is there inside that stuff? Okay, synchronous or asynchronous, I am not telling. It is a box which has important issue is we have inputs here. Already. Okay, so inputs are there. So I will take. Okay, another one is a clear start. Okay, sorry. This is called clear. This is called input or preset or load. Another one is clock. The arrow indicates I am not exactly mentioning what will be the type of clock. It is not positive edge, it is not negative edge, it is not even the flat point. I told there will be a clock signal. That's all. Clock signal, no specifications. Right. Now I am saying this is a mod 4 counter. Okay. Now can I design this counter? This is there already. What is there inside? At present we don't want to understand. Okay. Can we design this? Yeah, 0 1 1 1 is there. Then afterwards it has to go 1 0 0 1 1 0 1 0 1 1 1 1. Then afterwards it should repeat.
Yes, ma'am, we can design.
How? Can clear it, na? Because here the counting sequence, we have no idea what is happening. I am only checking out this. What I will do? Then see, if this is input. What goes next? I have no idea. Right? With the illusion that next state is this. With an illusion next state is this. Next state is this. When I clear it, it will start the process. Again, it will input here. Did you understand? Till now, what is there inside? I am not revealing. Input is provided like this. Then when all the outputs are equal to 1, then it will clear. Once the clear is there, again a fresh input will load. Fresh input is always this. Okay, now what can be there inside? What could be there inside? Will it be synchronous or asynchronous?
Synchronous counter.
Yes, it is a synchronous counter, right? So at present, what you have designed earlier, right? You designed for this, TATB is there, TC is there, TD is there. That is what there in the box. Okay, so now this one, this is the schematic view. What you have done earlier. Okay, that is totally your inside structure. This whole setup is called modulo 4 counter. Like this, so many counters you can design, but it will be synchronous. Remember that. It cannot be asynchronous. So I think this one will rub off all the illusions what you have. Modulo counters, if at all you are designing for such type of sequences, you can do that using synchronous mode. Now, hold on. If at all I want to get a state like this, this is mod 5 counter. Okay, I am telling it is mod 5. Why? Because 1, 2, 3, 4, 5 states it is going through. Okay, it can be 3-bit, 4-bit or 5-bit, anything. No problem. Consider this is 3-bit. Right. So can I design a mod 5 counter? Of course, yes. You can use synchronous one.
Yes.
Can I use asynchronous also?
Yes, ma'am.
Yes,
So
ma'am.
this is where, yes. Why? Because here it is in a sequential work. Sequential one. So in that mod 5 box inside, whatever you design, you can have an alteration. You can keep it asynchronous, you can keep it synchronous. Why you are telling asynchronous very confirmly? Because it is following one after another, and it is very clear if at all you use JK flip-flops and keep all the things high, it follows that. That is already a known thing from its characteristics. Even if you take T flip-flop also, T is nothing but what? J and K tied together. Then also it will work out. Isn't it? Yes or not?
Yes, ma'am.
Yes.
JK
Yes.
and T. They are together. So this type of sequences you can easily keep that. Now, for example, I don't want inside stuff. I want this one to be designed in a box. I don't want the internal circuit. Can you tell how it will be? How it will be? This is mod 5, I am saying. Mod 5. Same thing. Clock. I will have input. Okay. Since it is only 3 bits I can use clear. Right? Then afterwards, let's say ABC. Right? So now what will happen? Very easy to. How I can take this one into that?
Ma'am,
Ma'am,
clear
We will
C.
take
B bus, C
A
bus.
as clear.
Yes,
B
it
bus,
can
C
be
bus.
connected directly to clear. So it will change the scenario. Now inside that, what is that? I will not ask. Right? So why? Because these counters are a generalized counters. These are called, we will say, just like universal counters. They can fit in any manner. Okay, since you people are doing one counter after another counter individually, so it will be a little headache for you, or it will be little what? Tough time for you. But there are counters which is available like already prefixed. What they will do, they can count any mod type of counters. Modulo n counter they will take. Modulo n counter. So you can see once you come back to this one, and you can check in the labs also. We have that. Right. So for your pen and paper work, this is very easy. I am not asking what should be there inside. Provided if I ask, you can open that and put it in a synchronous mode. Like this type is there. If this type is there, you can go for asynchronous. There is no rule that you have to use only synchronous, you have to use only asynchronous. Nothing like that. You should be very tactful to use which type will be better there. Asynchronous, if you are going, if a continuous sequence is there, you can go for asynchronous. Right, and there also you have two options, positive and negative. And moreover, I think in the first day class, before I fired you, I asked down counter, and some of you have told what is the small difference between the up and down counter is you are collecting the output. Collection of the output is the difference. Is that correct?
Yes, ma'am.
Yes, ma'am.
If you collect it from the regular one, it becomes a up counter. If you collect it from the complement one, it becomes a down counter. Is that correct?
Yes, ma'am.
Yes, ma'am.
Hold on.
Yes.
Can I mix up both? Means take that 3-bit counter up and down together. Like once it has to go to up, then afterwards it should start coming down. How I can trigger it? How I can do that on the same platform? Is there any way? Yes,
Ma'am,
it is
we
a
can use combinational logic.
not required, ma'am. Not required. You use the clear properly. Clear pin is there, no? For every flip-flop. When it goes up count. Okay. So what is the up count? 1, 1, 1. 3-bit. 1, 1, 1. So then afterwards, it should start down count. So can we combination logic come again? Come again? Somebody told? Sorry, I interrupted. Who told combinational logic?
Ma'am, Tanishq.
So how I should use? Where I should use?
Ma'am, it's like output like Q and where we are collecting, like we are collecting from Q or Q bar. So we can use a combination logic for Q and Q bar. Then
Combination
we can
logic for Q and Q bar means what?
and
I
we can
will,
give to the clock next flip-flop clock.
No. You have misunderstood my question. I am talking. You have to do an up count, then down count, again an up count, and then down count. It's like
Okay.
cycle.
Okay. Yes.
Now I want a cycle in that, up and down, up and down. So with any trick there, can I do the same circuit for both? Yes, combination logic can be done. And think of. Okay, sorry, I should not be interrupting. And if you can think of asynchronous one also, it will be good. Simultaneously up and down. That's what we see. What you told us simultaneously up and down, na?
Yes, ma'am. Yes.
Simultaneously up and down you are telling. What is that? You will say that you will have 3-bit like this. Correct? So now
Yes.
you will take Q and you will take Q bar also. So this will show your up. This will show your down. That's what.
Yes, ma'am. Yes, ma'am.
Okay. What about the clock situation here? Tell about the clock. What clock it will work?
That is asynchronous, ma'am.
You want asynchronous? Hold on. I will be back with you. Asynchronous means I will connect this one. Is it negative?
Negative trigger.
Okay. Then I will connect like this.
Yes, ma'am.
Okay. So wait a minute. So all these are high. Okay. This one goes without high. This is high. This is high. Now this question is for everyone. Please try hard to disprove Tanishq. This is high. Okay. He is saying that simultaneously if you collect or count here and here, you will get up this side and down this side. That is what? Up count in this and down count in this side. Is that correct?
Yes.
Correct? Okay.
Yes.
So this is A, B, C. Now, he told in asynchronous, please try to re-verify because timing diagram you can draw, no? Q and Q bar. Q and Q bar. Okay. So this is question is everyone. I want that. So that we can master this. It's very, very good. Very good. Up and down simultaneously. Let's see. Can we do that? I will again redraw. The same thing I am redrawing. Don't worry. Check out. He is claiming that. See, no hard feelings, Tanishq. It can be right or it can be wrong. Okay. So just check out whether he is telling that Q and Q bar. I am much interested in this. Q and Q bar. Okay. This is A. This is B. This is C. Okay. And this is showing up. You take LSB or MSB. In that also I have no rules. Right. You tell me this is MSB, I will take that. This is LSB, fine. After drawing this, timing difference. And this is negative edge. That's what he told. Okay. So this is connected. Right. So J and K. These are high. 1, 1, 1, 1, 1, 1. Okay. Then What is this? Tells that I should connect it. Okay, W, X, Y. I'm totally giving different names. This is down count. That's what he told. Now with this, with the timing diagram, try to draw ABC, try to draw WXY. Means once A you have drawn means that time W also should come. Once B you will draw, that time X also should come. C you will draw, Y also you should get. Okay, so then check out seriously, then we will extract separately ABC and WXY. And are we getting up count and down count there? That's what I wanted to. Question is interesting or not?
Yes, ma'am.
Yes, I think, can we do this? See, Q bar, W, X and Y, Q bars are, and A, B, C are Qs. Okay, so if you want to draw separately are A and W, B and X and C and Y, your wish. Your timing diagram has to decide. So, but it's very interesting. Let's prove or disprove this. Otherwise, I'll not leave you. Everybody, if you are completed, please post. Seriously, I need to see. Abhijit?
Yes, ma'am.
Yes, ma'am. Yesterday you have asked a question. Afterwards, it came to my Jindra. Regarding the clear, right?
Yes, ma'am.
You are clear now?
Yes, ma'am. Now I'm clear, ma'am.
You asked about clear. How it is clear? Good.
Yes, ma'am. I'm clear.
Very nice, very nice. Good, good. Hey, this one you solve. It will be very interesting. Seriously,
Yes, ma'am.
I have never made the students work like this. I think last batch I have made them. Yeah, I made them. Then afterwards they could understand like what will happen. Right, Tanish, is that Tanish who proposed this stuff, Siri?
What? Excuse me, ma'am.
Tanish proposed this thing, na?
Hello.
That Tanish.
Yes, ma'am. Yes.
Yes, yes. So whole class is after approving Tanish or no?
Ma'am.
Yes, ma'am.
Ma'am.
Aishman,
Ma'am.
go ahead.
What if we add another JK flip-flop and take that its output to choose when we are doing up and when we are doing down? So for half cycle we will be taking up for the output of D, and for another half cycle we will be taking down.
Hold. Aishman, that is 100% eligible, right? Okay, I will grant that. You are doing and designing a new theory, correct? And we can choose up and down, that is choices with you. But at the same time, you are increasing the hardware. Embedded people will not agree. Because you have unnecessarily wasted one more JK flip-flop, no? It counts. See, we are going for miniaturization. You are going again back to pavilion. Like you are increasing the burden, right? You design 100% acceptable. We can take another flip-flop and then choose 100%. But with this one, can we get or we don't get? That is what my question is. Are we getting?
Ma'am, we won't get.
No. Are you getting?
Ma'am, we are getting 11011000. It should come 111001 and 00.
Hold on. Shweta, hold on. Is that Shweta?
No, ma'am.
Who's that?
Sulabna.
Sulabna. Yeah, your voice. Okay. So what is that one? Please come repeat slowly. What is that you are telling? You should get?
Ma'am, no, ma'am. For down counting, we are getting 1101.
No. No. Tell in decimal digit. That is easy.
Ma'am, 3, then 1, 2, 0.
3-bit now. You should get 8 numbers.
No, ma'am, I have taken only 2 bits.
Oh, you have taken only 2-bit. Okay, she'll input 1. Super. Good idea. What did you get? You got 3. You got then
1, 2, 0. 2,
Oh, it's
0.
not down. Then it's wrong.
Yes.
Whereas up you got correctly 0, 1, 2, 3.
Yes, ma'am. Got up on.
Okay. Right. Now up is okay. Tanish, this is not there. So how many people have faced this?
Ma'am, it's coming. Means if we use for 3-bit counters also, it is coming.
Wait. If I use the same thing, it is coming. If I use the same, not 3-bit counter, I am talking about this circuit. Is it working? I mean, this is also.
Yes, yes, ma'am. I had drawn the clock pulses. It's coming for up counters and down counters.
Can you just post it, ma?
Yes, ma'am.
Yeah, please see. Clock is there. Then afterwards, A, B, C. I have to see only the ABC timing diagram. I will follow that. Either anything, LSB or MSB, I can change that. And WXY, that timing diagram. That will decide whether you will get a ABC or, I mean, up and down or not. See, even if you reverse also, this side up and that is down, no problem. Yeah.
Hello, ma'am.
Yes,
Ma'am, can you use preset after getting 3? Ma'am, when I'll get 3, then after getting preset, then the order will be declared like 3, 2, 1, 0. Ma'am?
Okay, you want a preset to be utilized. Okay, that means
Yes,
for
ma'am.
this it's not coming without using. Okay, so Sulagna, you have one vote. So Sulagna didn't get another one. I don't know your name. Okay, so how many people didn't get with this type of circuit? I strongly believe you cannot get, but some are straining, some are working out hard. Some are working out hard, so you can try. No problem.
For down counter, we should connect the Q bar to the clock, I think.
Okay, so Q bar to the clock for down counter, and then up counter.
Q.
How? Then you are changing the circuit for me.
Ma'am, that is what I'm saying, na. For suppose our circuit should be like output should be like 1, 2, 3 and 2, 1. For
So
1, 2.
You are telling to find out a combinational choice. I don't want to use another flip flop. I will use a combinational choice when to use up and when to use down, so that my clock will accordingly follow. That's what you are told, correct?
Yes, ma'am.
But I don't want to do that. Give me a way. I don't want to waste. Oh God. Yes, somebody has posted. Let me see. Swallow. Yes, swallow. I don't want to use. I am so okay. Everybody can see, I guess. Swaroop, can you explain this one, ma? What is this? Counter output? QA, QB, QC. What is this? Swaroop, can you unmute and tell?
Hello.
Yeah, I can listen. There.
Ma'am, in the first figure, I drawn for.
Oh, you have changed it. You have drawn asynchronous down and up separately.
फोन बार बार हमको कर रहा जो ना. Hello, am I audible?
Yes, sir. Yes.
Ma'am, Ma'am, in the first figure, I drawn for 3-bit asynchronous up counter, and in the second, down counter. And I'm getting the clock pulses as required.
No, not that way. I was asking something else. I'm not asking this way. He has given two different. I don't want two different. Swaroop, I want both in same. Aishma?
Yes, ma'am.
Are you understanding? What did he do is like two different circuits he has given.
Ma'am, I don't think we can get a up counter, down counter, which will count till up and then go down.
Oh, you don't think it's not? Okay, small clue I will give. I was thinking, right, I don't know, I'll give the clue and leave it. This particular one, if you connect to clock, it will work, might be not negative. Take a positive. Think. Q bar, right, I'm not drawing. Q bar connecting to the clock pulse of the next one, clock of the next one, but not in the negative edge, in the positive edge. Maybe it's just a count, just an intuition. This one connecting, and you will get both up and down. Think so. Can you try? Use positive. Okay, again I'm telling you, can write it down. Use a positive connection, right? Use a positive connection. I'll do in blue. Okay. So connect it here. Use positive trigger. This one no more negative. It is also positive. Or so this one over here positive. Rest remain the same. Maybe it will work out. Right? Can you people try? So if worked out, post.
Hello.
Yes.
Ma'am, can you repeat, please? Ma'am, can you repeat what are the conditions that you have changed?
I didn't change anything. In the blue it is there already. What I did is Q bar I have connected to the clock pulse, but it is not a negative clock pulse, it is a positive clock pulse. Positive clock pulse. I am doing it as positive. Here also positive. Here also positive. All will be positive for me right now. Okay? No more negative. Connected like this. Asynchronous. Right? And clock pulse. Go ahead and then check out whether you will get up and down or not. Okay? Try. So this one won't be there. This is not connected. Q bar is connected. Q bar is connected. Okay? This is what I am proposing the change. You can just check. Is that okay? Everyone? Somebody told I don't think you will get, but it's existing. Yes, are you guys there?
Yes, ma'am.
Yes, Swaroop. Now totally in the same circuit. No combination circuit used. Extra. Ganesh? Sulagna? Yeah, Sulagna, you try this one for your 2-bit counter. Shweta?
Yes, ma'am, I'm trying.
Yeah, try it. Abhijit, you also try this trick.
Yes.
If it works, fine.
Yes, ma'am.
What? Is work? Is it working? Share the good news. Okay, I'll be waiting. It didn't work. So Sulagna can give fast because she is only doing 2-bit. Oh, somebody is showing hand raise. Who is that? Whose hand is raised? Shweta?
Yes, ma'am.
Just check out somebody hand raise is there and somebody wants to tell something. Just check out. I am unable to. Ahan, is that you?
No, ma'am, my hand is not raised.
Ma'am, somebody sent in the chat box.
Okay, I've sent in the chat box. Okay, just. Well, this is Swarup, ma. We have seen already this one, Swarup, and he has given two different circuits. I want in the same circuit. Sulagna,
Yes, ma'am.
worked out? Because you are the one who first pointed out 0, 1, 2, 3 up is very good, but down it's not working. But maybe with the positive trigger and the Q bar connected.
Yes, ma'am. It's working for down counter now.
Now
I have to check the up one.
Yeah, good. Go with that.
Ma'am,
Yes.
I lost my network for some time. This is Swarup. I lost my network for some time.
What happened?
So the two pictures that I posted, are that correct?
No, two different pictures you posted. Two different, it is correct. But I want both to be done with the same circuit. You have used negative clock pulse, it's correct. Up counter, down counter, asynchronous, two separate is 100% correct. But I want together. 1, 2, 3, 4, 5. I want both in the same one.
Yes, ma'am. We can take the output through QA dash in the same one also.
That's what Sulagna has already done, but her down
same.
counter is not working. Down counter didn't come. Check out your down. If you can take the output from the Q bar, right, with the same negative triggering, it is not working. Down counter is not coming.
Hello, ma'am.
Yeah, I'm there. Please go ahead. Tell.
Ma'am, it's working.
Sulagna, so happy. You should tell why you are so sad. It's working. Huh? You are happy? Okay. So it's working. Yeah.
But ma'am, the up and down counter is we are getting both the counters simultaneously. I mean, it's not counting up and then down. I mean, it's we are getting both the
simultaneous. See, up and down is a cycle, right? So now simultaneously we have that easy to break that and then give. Other already has proposed. We can use a combinational circuit. Then first finish off the up, then do the down. That is already told. Tanishka, somebody has already told.
Okay, ma'am.
One has already proposed. That is starting itself. We can use another flip-flop, you told. Then I told use a gate, then you can work out. That has, I think Ayushman has told. Somebody has told. Okay, so we can use a combinational logic and then say that, okay, first finish off your up, then I can go for down. Right. Then afterwards my greed increased. Then I told, why don't we try for a simultaneous one? So in between that you missed. I think this will work. This is simultaneous up and down.
Yes, ma'am, it's working.
Yes. See, this is just like that will not come. It's experience. That's all. Asynchronous requires a lot of insight. See, positive only why I should use. You have started with your negative. It didn't work. But there, if you check the patterns carefully, there itself clues will be there. Because our eyes, what it will do, we will go for the negative only. We will not scan the positives that time. You check the positives, maybe it will work. So this is a visualized exercise. You visualize and analyze. Right? In the negative one, if at all you are going, you are not getting. Then immediately it should strike. Maybe with the positive it can come. Maybe. Right? So it is experience. You will also get, if you continuously draw the pictures, draw the timing diagrams, then you will get to know how to do this. Okay? So now you should not be getting any doubts in this. Anything you can do. Asynchronous, synchronous, anything you can work out. Mod counter, everything you can get. See, it's not rule also that only Q should be connected. Q bar also can be connected. Q bar also can be connected. No issues. Right. Asynchronous, no rules. Do anything, whatever you have. Okay. So now go enjoy your lunch. Right. Tomorrow we'll meet it. Thank you. Any doubts you can post now.
Thank you, ma'am.